When learners first hear the phrase software inventory, they often picture a list of installed applications on office laptops, and they wonder why it matters in operational technology, OT, where the focus seems to be controllers, sensors, and physical equipment. The truth is that OT environments run on software in many places, and the software often determines both the capability and the risk of the hardware it lives on. Engineering workstations run configuration tools that can change controller logic. Operator interface systems run human-machine interface software that shapes what operators see and how they interact with the process. Servers run historians, remote access services, and management functions that connect IT and OT. Even specialized appliances often run embedded operating systems and firmware that can carry vulnerabilities and misconfigurations. Maintaining software inventory and mapping it to hardware is how you create visibility that enables decisions, because most important security decisions depend on knowing not just which boxes exist, but what code is running on them and what that code can do. Without that visibility, patch planning becomes guesswork, incident response becomes slower, and recovery becomes less trustworthy because you cannot prove what should be installed. In OT, where uptime and safety matter, the ability to make evidence-based decisions is one of the most valuable outcomes of good inventory practice. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. Software inventory is the practice of tracking what software components exist in the environment, including operating systems, applications, services, libraries, drivers, firmware, and configurations that materially affect behavior. For beginners, it helps to think of software inventory as the behavior definition of hardware. Two identical servers can have very different risk profiles if one runs a remote access gateway and the other runs a historian, even if they look the same on a rack. Two identical workstations can have different risk profiles if one has engineering tools installed that can push logic changes and the other is used only for viewing dashboards. In OT, even small software differences can change what actions are possible. A workstation with a programming suite can directly influence physical process behavior, while a workstation without it may not. Software inventory therefore supports criticality and least privilege by helping you identify which systems have high-impact capabilities and should be protected more strongly. It also supports troubleshooting because knowing versions and configurations can explain why one system behaves differently than another. Beginners sometimes assume software inventory is only for compliance, but the real value is operational clarity. It helps you understand what you are running and why. Mapping software to hardware is the step that turns a software list into a decision tool, because decisions are almost always about a specific asset and its role in the process. A software inventory without hardware context is like knowing ingredients without knowing which dish they belong to. In OT, mapping means tying each software component to a specific hardware asset identity, location, owner, and function. This mapping helps you answer practical questions quickly. If a vulnerability is announced in a specific operating system version, you can identify exactly which servers or workstations run that version and whether those systems are in sensitive zones. If a particular remote access tool is found to be misconfigured, you can identify which jump hosts use it and what segments they can reach. If an engineering tool is installed on a system outside the controlled engineering environment, mapping reveals an unnecessary capability that expands attack surface. Beginners should also understand that mapping supports containment decisions during incidents. If malware is detected on a workstation, you want to know what software is on it that could be used to pivot, such as remote administration utilities, file transfer clients, or management agents. The mapping creates a clearer threat model because it connects code to capability and capability to consequence. A particularly important part of software inventory in OT is distinguishing between different layers of software, because different layers have different update pathways and different operational risks. Operating systems matter because they provide the foundation for security controls, logging, and compatibility. Applications matter because they define business and operational functions, like engineering suites, operator interface software, and historian services. Firmware matters because it can contain vulnerabilities and because it affects device behavior in ways that are hard to observe. Configuration matters because the safest software can become risky when misconfigured, especially for remote access, authentication, and network services. Beginners often focus on application names, but in OT, firmware versions and configuration baselines can be equally important, especially for network devices that enforce segmentation and for appliances that provide monitoring and access control. Software inventory should therefore capture enough detail to support meaningful decisions, not just top-level product names. This does not mean capturing every file and every patch in perfect detail, but it does mean capturing the attributes that change risk and supportability, such as major versions, support status, and known critical settings. In a high-consequence environment, we think it is updated is not a strong enough statement. Software inventory is how you move toward we can prove what is installed and what version it is. Why does software inventory matter so much in OT security? One reason is vulnerability management, which is the ongoing work of understanding exposures and deciding how to reduce them safely. You cannot prioritize vulnerabilities if you do not know where affected software exists. You also cannot plan patches responsibly if you do not know which systems run software that is sensitive to change or requires vendor coordination. In OT, patching is often slow because updates may require testing, maintenance windows, and validation of process stability. That makes it even more important to know what you have, so you can focus effort where it matters most. Another reason is incident response. When something suspicious happens, responders need to know what software could be involved, what tools might be abused, and what dependencies exist. A third reason is resilience and recovery. After an incident, you may need to rebuild systems or verify integrity, and software inventory provides the baseline for what should be installed. Without a baseline, recovery becomes improvisation, and improvisation in OT can create safety risk. Software inventory therefore supports prevention, detection, response, and recovery, which is why it is foundational rather than optional. Maintaining software inventory also helps detect drift, which is the slow accumulation of changes that cause environments to become less predictable and less secure. Drift can happen because of emergency fixes, untracked vendor installations, ad hoc troubleshooting, or gradual changes in configuration over time. In OT, drift is dangerous because it erodes determinism and makes anomalies harder to interpret. If software changes occur without being recorded, then unexpected behavior might be dismissed as normal because nobody knows what is supposed to be normal. Drift can also create hidden attack surface, such as when a remote access tool is installed temporarily and left behind, or when a service is enabled for troubleshooting and never disabled. Mapping software to hardware makes drift easier to detect because you can compare what is installed now to what the inventory says should be installed. When you find discrepancies, you can investigate whether they are legitimate and documented or whether they represent unmanaged risk. Beginners should see drift detection as a major practical benefit of inventory work. It is not only about knowing what exists, it is about knowing when reality deviates from the intended design. That knowledge allows you to correct issues before they become incidents. A common beginner misunderstanding is that software inventory must be perfect to be useful, and that belief can prevent organizations from starting. In reality, a partial but accurate inventory focused on high-impact systems is far better than an exhaustive but stale inventory that nobody trusts. A practical approach is to prioritize the systems that have the greatest ability to influence operations or to act as bridges between zones. Engineering workstations, remote access jump hosts, historian servers, and boundary devices are often high on that list. Capturing software on these systems yields immediate security value because it informs access control, monitoring, and incident response. Over time, inventory can expand to include broader sets of endpoints and embedded systems. Beginners should also understand that different assets require different inventory depth. A general-purpose server might support detailed software tracking, while an embedded device might be tracked by firmware version and critical configuration only. The goal is consistency and maintainability. If the process is too heavy, it will fail under operational constraints. If it is too light, it will not support decisions. The sweet spot is capturing the information that actually changes what you do and then maintaining it through disciplined workflows. Maintaining the inventory over time requires integrating it into how work is done, because software changes happen through maintenance, projects, and vendor support, not through inventory teams working in isolation. That means software updates should be tied to change management so that when a system is patched or a new application is installed, the inventory is updated as part of the same operational record. It also means there should be periodic validation, where you compare recorded software states to observed states and investigate mismatches. In OT, validation must be planned carefully to avoid disrupting sensitive devices, but it is still necessary because assumptions become stale quickly. Another important point is ownership. The inventory must have accountable owners who are responsible for keeping software records current for certain asset categories. If everyone owns it, nobody owns it. When ownership is clear, updates happen more reliably and drift is reduced. Beginners should recognize that inventory maintenance is not glamorous, but it is one of the highest leverage activities in OT security. It is the difference between responding with evidence and responding with guesswork. Mapping software to hardware also enables better communication across teams because it provides a shared language that connects operational function, technical reality, and risk. Operations teams can see which systems are critical and what changes might affect them. Security teams can see which software creates exposure and where monitoring should focus. Engineering teams can see which tools and versions are in use and whether they align with vendor guidance and supportability. This shared visibility reduces conflict because debates can be grounded in facts. For example, if a security team wants to disable a service, the inventory can show whether that service is required for operations or whether it is leftover from a past troubleshooting effort. If an operations team resists a patch, the inventory can show whether the affected system is a high-risk bridge and whether compensating controls are needed. This is what it means to enable decisions. The inventory does not make decisions for you, but it provides the evidence and context that allow humans to decide safely and confidently. In OT, that confidence is vital because the cost of wrong decisions is high. A well-maintained inventory reduces uncertainty, and reducing uncertainty is one of the strongest forms of resilience. In the end, maintaining software inventory and mapping it to hardware is about making the environment understandable and defensible over time, even as systems age and change. Software defines what hardware can do, and in OT, capability and consequence are tightly linked. By tracking operating systems, applications, firmware, and critical configurations, and tying that information to specific assets with clear roles and locations, you create visibility that supports safe segmentation, targeted monitoring, smarter vulnerability management, and calmer incident response. You also build a baseline that makes recovery more trustworthy because you can restore systems to known good states rather than hoping that reinstalling is enough. For beginners, the most important takeaway is that inventory is not a bureaucratic exercise. It is a practical safety and security tool. When you know what software is running where, you can reduce unnecessary attack surface, focus protection where it matters, and respond to surprises with evidence instead of panic. That is what visibility that enables decisions looks like in OT, and it is one of the most important foundations you can build early.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.